Hello, and today I'm going to be talking about how to use trigonometry to solve for an angle. So, if we had a triangle like this, and we knew some of the sides, right? Two of the sides, and we knew that there was a right angle in there somewhere, and we wanted to work out what this theta is. Well, we can work this out by using the appropriate trig ratio. So let's write the mnemonic. So car toa. Okay. Now using the mnemonic, we can work out how we're going to work out what theta is. So in this case, we know opposite and we know the adjacent. So let's label them opposite and adjacent. So we can use tan. Tan deals with opposite and adjacent, so we can say tan theta is equal to opposite 3 divided by adjacent 4. But we want the angle here. So what we can do is we can say that theta is equal to tan to the power of -1 of 3 over 4. And whatever this comes out to is the angle of this triangle here. So, a couple things to be aware of. There are 3 different ways of expressing an angle. The most common one is the degrees. So there's 360 degrees in a full revolution of a circle. But there's also something called radians, where 2 pi is a full revolution. And there's also something called gon or gradients, which a full revolution is 400. So you have to be careful in making sure that you select the appropriate measurement to the question. Typically, questions like this are either in radians or degrees, but for now let's just talk about degrees. So here I can use my calculator to work out what theta is. So theta is equal to -tan of 3 divided by 4. And we can see here that it's around about 36, 37 degrees. So I'm going to round to 2 decimal places. So theta is equal to 36.87 degrees. As usual, you have to be careful with units, because like I said, there's 3 different measurements. 36.87 could also mean centimeters. You have to specify. Theta is an angle, therefore it's in degrees. So, what if we wanted, we didn't know what that side was, but we did know that this was 5, and we wanted to work it out, what angle theta is here. So we can use our previous method, or we could just use a different trig ratio. So cos deals with adjacent and the hypotenuse, so I've labeled them there. So cos theta equals the adjacent 4 over the hypotenuse 5. So theta equals cosine to the -1 4 divided by 5, and that'll work out what theta is. So let's do that. theta is equal to negative cosine of 4 divided by 5, and we can see we get theta is equal to 36 point, rounding to 2 decimal places, 87 degrees. It's the exact same degrees, and you'll see that when we go to do sine, it's going to give us the same angle. So let's do sine now. So with the same triangle, the sine of theta. So let's say we only knew these two. We have the opposite and the hypotenuse. O and A. What deals with O and A? Sine does. Sine theta is going to equal opposite 3 divided by hypotenuse 5. So theta is going to equal sine to the negative 1 of 3 divided by 5. So let's do that. So negative sine divided by negative sine 3 divided by 5, and we get theta equals, rounding to 2 decimal places, 36.87 degrees. Now, this is a representation of an angle here, 36.87 degrees. But if we want to get more precise, we can convert this into something called degrees, minutes, seconds. So on a calculator, it's going to look something like DMS, but because of my calculator, it's slightly different. So if I want to represent this in degrees, minutes, seconds, I can say that this is 36 degrees, 52 minutes, and 11.6315 seconds. So often in questions they will ask you to round to the nearest degree, the nearest minute, and the nearest second. So if I'm rounding to the nearest minute, I don't write this seconds thing here. I could write 0 seconds, but that's not required. And there we go. And this is used for longitude and latitude in describing an angle along the surface of a sphere. But let's not worry about that too much. So now that we know what theta is, and we've confirmed it with 3 different trig ratios, what if our angle moved? Let's say we want this angle here. This is our new theta. We'll have to relabel our triangle. So there we go. So what deals with adjacent and the hypotenuse? Cosine does. So cosine theta is going to equal the adjacent 3 divided by the hypotenuse 5. So theta is going to equal inverse of cosine 3 divided by 5. That means theta is equal to, going back to the screen, negative cosine of 3 divided by 5, and we'll convert it into degrees, minutes, seconds, and I'm going to round to the nearest minute, 53 degrees and 8 minutes. Now the reason why I rounded it to 8 minutes is because looking at the seconds, it's grouped in 60s. So if so, just like actual minutes and seconds, there's 60 seconds in a minute, and there's 60 minutes in a degree. So I can prove that on the calculator here. So if I want to work out what this is in degrees, minutes, seconds, like so, I can push the degrees, minutes, seconds button. It might look something like a degree and 3 commas like that here, but for the most part it will look something like DMS, depending on your calculator. So if I convert this into degrees, minutes, seconds, and we will see that 60 minutes is a degree. So I can change this slightly, so there's 0 seconds, 0 minutes, and I'll make it 60 seconds, and we can see again it is 1 minute. So that's all I have time for today for solving for an angle in trigonometry. If you have any questions, feel free to ask me in the comment section below, and I will contact me on social media, and I will see you in the next video.